Good morning, Trailblazers. This is Mr. Parrish. I just thought I'd give you guys a quick little review before you took your common assessment today, but I know you're going to do great regardless, so we're just going to go over a couple things that might help you out right before the test. The first thing is naming acids. I noticed a couple of you have been struggling with naming acids over the past few weeks, so I thought I'd do a quick review on that. Remember, there are three types of acids. There are acids that have no oxygen, there are acids that have an ATE polyatomic ion, and there are acids that have an ITE polyatomic ion. If it has no oxygen, that means it has to start with hydro. Hydro does not mean water, it does not mean acid, it means there is no oxygen. If it ends in ic, the polyatomic ion should end in ate, and if the acid ends in OUS, then the polyatomic ion should have to end in ITE. You don't have to write any of this down. You can write down any notes that you need to at the top of your sheet where there's a little box that says notes to remember about acids. There's basically three steps to identifying an acid. You have to first identify which type it is, and then use the anion to figure out which part of the name to use, and then add acid at the end. I think you guys are familiar with this process. Remember, you should always write down atic-itis on your periodic table. It will help you memorize the acid formulas. The only one that's not listed in atic-itis is, of course, hydro. We're just going to skip this slide. You guys know what to do. Okay, here are some examples of acids. I want you guys to try to name these. If you don't have a periodic table, this first one is sulfate. The second one, you should know what to do with that. And ClO2, that is chlorite. So you should know what to do with that. All right, I'll give you about, let's say, 90 seconds to name the acids or write the formula for it. Oops. About one more minute. Okay, if you're going to name this acid, this is sulfate, so that means the acid has to end in ic, so it becomes sulfuric acid. HBr does not have an oxygen, so it must start with hydro. And of course, this is bromine, so you add the stem bromine here for hydrobromic acid. This is chlorite, which means the acid has to end in OUS, so this becomes chlorous acid. So I used atic-itis for these, the first and the third one, and then this one doesn't have an oxygen, so I have to use hydro. Phosphoric acid is H3PO4 because this ends in ic, so that means you need phosphate. So when you look up phosphate, it's PO4 with a charge of -3, and then I'm gonna put that 3 right down here next to the hydrogen. This is hydrosulfuric acid, so that means there is no oxygen. It is just hydrogen and sulfur, so you put a 2, or the charge of sulfur is -2, so you put a 2 next to the hydrogen. All right, transitioning to nuclear, some quick stuff you might want to remember about nuclear. Some of this chart is filled in for you, but I'm going to let you fill in the rest on your own. I'll give you about 30 seconds to fill in the boxes that are not listed for you. There won't be a ton of questions on nuclear, maybe 2 or 3. I just thought it'd be something that would be like easy to go through right now. There are 3 types of electromagnetic radiation, alpha, beta, and gamma. Remember, alpha is the biggest one. It's kind of the slowest and weakest one. It has a mass of 4, so it makes it quite large. Think of like a bus, like hard to move around. The charge is +2, so it would be attracted to a negatively charged thing. A beta particle is -1. When you're writing beta decays, remember that the number of the other element actually is going to increase by 1 because beta is -1. Electrons are very small, but they don't have no mass. And then their charge is -1. So beta particles would be attracted to like a positively charged something. Gamma is the easiest to write decay equations for because it has no charge, no mass, so it doesn't really affect anything. It's just pure energy being released. So alpha, big and slow, helium nucleus. Beta, very small and fast, but not like tiny. Sorry, is tiny, but not like nothing. And then gamma radiation, just energy, has no mass, has no charge. If you were to write this nuclear decay equation, I want you to try this on your own. So you have uranium-238, and it's going to undergo alpha decay. So I'll give you about, it shouldn't take too long, 30 seconds. All right, if you're going to write a nuclear decay equation, you have to start by writing the original element. So in this case, that's uranium. Uranium-238, so that means its mass number at the top is going to be 238. And then uranium's atomic number, the number of protons, is 92. It says it's decaying, so that means it's going to break apart into 2 pieces. We know one of those pieces is an alpha particle. So we start with the alpha. We start by drawing an alpha. And you can write 4/2 with helium, or you can use like the alpha symbol, like the little fish-looking thing. But it needs to be 4/2. And then you have to find the other piece that it's supposed to be. So the mass number needs to be 4 plus what gives you 238. So obviously the number is 234. And then for the atomic number, 2 plus what gives you 92. The number is going to be 90. So if we look on the periodic table and we look at element 90, you'll see that it is thorium. So that's it for nuclear decay. It's pretty straightforward. Just make sure that your top numbers, your mass numbers, are equal on both sides. 4 plus 234 is 238. 92 is equal to 2 plus 90. Really straightforward. You guys were great at this stuff, so I thought I'd just remind you of the particles. All right, heating and cooling curve. Remember, a heating curve starts as a solid and works its way up. So it goes from like solid to melting to liquid to vaporization to gas. This is your melting point and your boiling point. More importantly, I want you to label where the kinetic energy is changing and the potential energy is changing. I'll give you 20 seconds. Label on the graph where the kinetic energy is changing and the potential energy is changing. Okay, if you remember, I gave you an acronym for remembering this. Kill, perish, kill, perish, kill. Okay, I know it's not the most flattering of acronyms, but it's effective. It starts with kinetic anytime you have each phase, so solid kinetic, liquid kinetic, gas kinetic, and then during the potential energy changes, that's where the phase change takes place. So remember, potential starts with a P, phase starts with a P. So during the melting and vaporization, that's where you would see the potential energy changes. The difference between kinetic and potential energy is kinetic energy goes towards like the temperature. So if the temperature is changing, you can see here on the y-axis the temperature is changing, and then on the x-axis you have time. So where there is no temperature change, that's where the potential energy is changing. Where there is temperature change, that's where kinetic is changing. Kinetic means motion, so that's like more to the motion of the particles, and potential energy is more like a rearrangement of the particles' position to change their phase. Okay, that's all the time we have. You guys are going to do fantastic. I told you yesterday in class that I am 100% confident in your abilities. Just make sure that if you are answering the questions that you are supposed to answer. So if you're someone who is used to answering all the difficult questions in chemistry, you should be trying them all. If you're someone who is going to find the easy questions first and then work your way towards the hard ones, you need to be strategic in that strategy. On the back of your chart right now, I want you to draw the molar roadmap, and then in 1 minute I will put up the answer. So turn your sheets over and draw the molar roadmap from memory. There's your answer to the molar roadmap. So hopefully this is a tool that you will find useful on the test, and if not, then you probably are good at stoichiometry anyway. So like I said, guys, you're going to do fantastic. Just make sure you try your hardest during the entire test. Don't leave anything blank on the free response. Good luck.